There are a couple of ways to create a slot in SOLIDWORKS with a rounded bottom. Here I have a simple block, which represents my stock. One way to create a slot with a rounded bottom is to simply create a regular slot and to use a full round fillet to round off the bottom. I'll start a new sketch on the top of this block. I'll use the slot tool to sketch out the slot, and exit the sketch. Now, I'll use this slot sketch to create an extruded cut feature. With the slot created, I'll launch the fillet tool. I'll choose full round fillet and select the side face, the bottom face, and finally, the other side face. And I'll click the green check to finish the fillet. When I switch to a section view, you can see the slot has the rounded bottom. Another way to do this is to use a swept cut. A swept cut is a good choice for a few reasons. Swept cuts provide a lot of flexibility regarding the geometry of both the slot and the profile. In this case, a ball end mill. Moreover, you can quickly make changes to either the profile or path sketches, and the slot will update automatically when you rebuild the model. A swept cut requires two sketches, one for the profile and one for the path. First, I'll sketch the path of the slot. I'll click on the top face and create a new sketch. I'll create an S shape for this slot path by first using the line tool. I'll use auto transition by returning my cursor to the end point of the lines to quickly create the tangent arcs. Now keep in mind that the path for the swept cut could be any shape you like, as long as it won't result in self-intersecting geometry. With the path complete, I'll exit the sketch and move on to creating the profile. First, I'll create a plane feature to sketch the profile on. I'll use the Normal to Curve option. I'll start a new sketch on the plane and create a U shape, once again using auto transition to quickly create the sketch. I'll make sure to close the profile. Next, I'll add some construction geometry and some dimensions to the profile sketch. I'll use this to define the depth and add a pierce relation. With the profile defined, I can exit the sketch and launch the Swept Cut tool. I'll select the profile and path sketches and click the green check to finish the cut. Now I can use a couple of full round fillets to round off the start and end of the slot. Finally, I can use a few constant radius fillets to round off the bottom corners. A third way to do this is to use a solid sweep, or in other words, a swept cut using a body. This is the most accurate way to simulate a cutting tool. First, I'll create the tool body. The tool body must be created using a revolved boss, or the solid sweep will not recognize the body as a valid cutting tool. I'll modify the profile sketch from the last swept cut, and create the revolve. Make sure that you have the Merge Results checkbox off. That way, the revolved boss creates a separate solid body. I'll launch the Swept Cut tool again. I'll choose Solid Sweep, select the tool body, I'll reuse the path again, and click the green check. You can see that the solid sweep very accurately simulated how an end mill would have cut this part. Now I'd like to point out one more last thing here. It's important to remember that a swept cut and a solid sweep will not always generate the same result. Here on this cylinder, I've created a swept cut feature by using a standard profile sweep. I used a circle for the profile and a helix for the path. On this cylinder, I've recreated the same sweep using a solid sweep, using the same helix, but with a revolved ball end mill tool body. While the two cuts were created using the same conditions and diameters, the results here are definitely different. I'll go to Add-ins and activate the SOLIDWORKS Utilities add-in. With the add-in activated, I'll next go to the Utilities drop-down menu and select Compare Geometry. I'll choose the Profile Swept Cylinder for the reference document, and the Solid Swept Cylinder as the modified document. I'll click Compare to launch the analysis. You can see from both the appearance of the comparison model as well as the results in the task pane that these features created distinctly different results. The green areas represent volumes that are common to both parts. The blue area represents material present in the profile sweep, but cut away by the solid sweep. And the maroon area represents material cut away by the profile sweep, but not cut away by the solid sweep. And keep in mind that while a swept cut may work for simple cases, when trying to model and simulate how an actual tool would cut a part, using a solid sweep is the more accurate method.